All right, guys, in an effort to make up some time but not rush through things, I decided to make a video for the modeling with equations video for you. So just to double back and go over the guidelines for modeling with equations. For part one here, it says to identify the variable. And again, the big question is, what does x stand for? Okay, and you really need to be able to answer that question, because we're going to use a variable in the equation, and we need to know what does that variable stand for. And then we're going to need to translate into algebra. Okay, mainly we're going to be able to set up a model, and by setting up a model, we're going to use these words to come up with some sort of a relationship. And so that's the big thing, is you need to identify a relationship between the values that we're talking about. Is this a distance equals rate times time? Is it an interest equals PRT, principal times rate times time? Is it a geometry question where we're going to use an area formula? Those kind of things. And then lastly, we're going to solve that equation, and most importantly, check your answer. Make sure that the answer makes sense. Again, we need to at least rule out, ridiculous answers, right? So we need to be able to rule out a ridiculous answer. And that's how you'll know that perhaps either your algebra went wrong or maybe the initial equation is the wrong one. All right, so let's move on. Just a word of caution. This video is like being in class, right? If I'm writing, then you should be too. Do the work with me, right? Don't watch me do it. Do it with me. Make sure you have a full set of notes. Unlike class, no funny sidebars in this video. Hope you don't mind. And you can pause me when I'm going too fast or rewind me to hear it again. All right, now we're really ready to get going. Again, just doubling back, we already talked about renting the truck, but just to go through it again, you have this rental company charging $65 a day, 20 cents per mile driven. And looks like Mike's going to rent the truck for 3 days, and he has a total bill. So I think our total bill is going to be equal to the number of days, right? The cost for that plus the mileage, right? The cost for the mileage. So I think that we'll call the total bill TB is going to be equal to, and up here again, it's $65 a day. So that's going to be the number of days times 65 plus the 20 cents per mile. So that's 0.20, because that's 20 cents. Notice right here, 65. Technically, we could have wrote, 65.00 plus 0.2 times the mileage. So now what do we have? We sort of have three unknowns. We have this total bill, the number of days, and the mileage. Now at the end of the day here, it says how many miles did he drive. So X is going to be the number of miles. And that's where I say you have to understand what X equals. So that means that we must know the number of days and the total bill. And we do. We know that the bill was $275. We know that the number of days was 3 times 65 plus 0.2. And we don't know the mileage, so that's our X. And now we just go through and do a little bit of algebra. So that's going to be 275 equals 195 plus 0.2x. We'll simply subtract 195 from both sides and then divide by 0.2. And we get an answer of 400. So the answer is 400 miles. But over here, I got my check. 400 times 20 cents a mile would give us $80. Plus the 3 days at $65 a day gives us $195. And when I add that up, I get $275, which is what it was stated as the original charge. So looks like we're in good shape. 400 miles is our answer. Let's move on. So next we're going to talk about simple interest, right? And when you borrow money from the bank or when you keep money in the bank, there's interest to be paid or earned. And so we have the players would be the principal, capital P. The interest rate is a decimal, lowercase r. I is going to be that simple interest that we're referring to. And T is generally our time in years. So let's see how this works in play. We have Phyllis investing $12,000, and a portion of that money is going to earn simple interest at 4.5% per year, and the rest, so $12,000 minus whatever the portion was, at a rate of 4% per year. And then after 1 year, the total interest invested the total interest on the investment was $525. I guess my first question was, why would anybody not put all of the money at 4.5%? But that's neither here nor there. So how much money did she invest at each rate? So how much money? So X is going to be amount invested. And so we're going to have to express an amount in two different accounts using the same variable. So we know that 12,000 was the total amount that she had, right? And so she invested X of it at 4.5%. And then the rest. Well, if there was 12,000 and she had X amount invested in one, then if you subtract that amount that she invested in one account, you would have the amount that she invested at the 4% rate. So interest earned is going to be equal to principal times rate times time. But really we have two investment pieces here. So really what we have is the first investment and the second investment. So they're made simultaneously with the same amount of time, giving us a grand amount of interest. So we know that that interest earned was $525. Now the principal amount that was invested at the 4.5%, we're just going to say, well, that's X amount of dollars times the 4.5%, so that's 0.045, right? And we're going to multiply that times time, which was 1 year. And now we're going to add that to that other rate. So the amount that is there is the $12,000 minus the amount we put in at the 4.5%. This amount is going to earn 4%, also times 1 year. So now we just need to clean up the right side a little bit. So 0.045x times 1 is just 0.045x. So that takes care of this piece. Over here, 0.04 times 1 is 0.04. So let's just call this 0.04. And then we have to distribute that to these two values. So after multiplying 0.04 times 12,000, I get 480 minus 0.04 times negative x is minus 0.04x. So now we're going to combine like terms, right? So we have the negative here and the positive here. That brings us down to 0.005x plus 480. Then we're going to subtract 480 and divide by 0.005 on both sides. And I get an x value of 9,000. Now you say, well, does that make any sense? Again, what are we looking for? We're looking to see how much money she invested at each rate. Originally, we were talking about an initial investment of $12,000. Now, it seems reasonable that we're going to invest portions of this in the thousands brackets. So I think 9,000 seems reasonable. So it looks like 9,000 of the funds were invested at the 4.5%. And then 12,000 minus 9 would be the 3,000 was invested at the 4%. Now this is what I would refer to as my final answer, right? Answer. But I just want to double check that. So if we check 9,000 times 4.5 and 3,000 times 4% for 1 year. So over here, I have my check. So it looks like I get $405 plus the 120 gives me the 525. That's what happened in the initial question. So I think that our answer is good to go. For this next problem, it talks about a square garden right? So obviously we're dealing with a square, and it has a walkway 3 feet wide around its outer edge. So essentially you have a square, right? And that's a right angle, and it has a 3-foot path that goes all the way around it, like such. And so that's 3 feet, and that's 3 feet, and that's 3 feet, and that's 3 feet. Object not drawn to scale. And it says that the area of the entire garden is 18,000 square feet. What are the dimensions of the planted area? So what they're asking for is really the dimensions of the square. So first we have to think in terms of our geometric shape. So we have an entire length and an entire width or height, however you want to look at it. So if the original dimensions of the blue piece you don't know, then I guess we're going to call that x. So this will be x. And the height will also be x because it's a square. Now if that were all we were talking about, then we would say that x times x equals the area, or x squared equals the area, because that's the area formula for a square. But that's not the entire area. This whole length is x plus something. And you have to think there's 3 feet on this side and there's 3 feet on this side, so that's x plus 6. And then the whole vertical length is x, right? This length was x plus a 3 here and a 3 here. That's another x plus 6. So what we have is x plus 6 times x plus 6 equals the area. Now we know that the area is 18,000 square feet. So I'm just going to go ahead and I'm going to flip these sides and say that 18,000 equals x plus 6 all squared. And it should be noted that x is the dimension of the square garden. So what we have here is a quadratic. And what we're going to want to do is expand this. So although it's cutesy to write it this way, it's probably better to think about multiplying it out like this. So we have a binomial that we want to square out. So that's going to be 18,000 is equal to x squared, right? What we're doing is we're foiling over here. So first, outer, inner, and last, that kind of thing, right? So, and I actually didn't connect it in the right lettered order, but we should know how to FOIL. So x times x is x squared plus 6x plus 6x plus 36. And then we're going to have 18,000 equals x squared plus 12x plus 36. So in terms of solving a quadratic, we want to be able to set the term equal to 0. So we need to subtract 18,000 from both sides. All right, and as you see, I have written down the quadratic formula. This is not going to be something that's fun to factor, even if it is factorable. I'm just going to assume it's not. And I'm going to write down, since I've got it set equal to 0, I have my a value here, my b value here, and my c value here. Don't forget that the signs are right in front of them. So there's a plus here. So it's a plus 1. That's a plus 12. And then this is a negative 17,964. So I'm going to go ahead and process all of that and say that's negative 12 plus or minus the square root of b squared. So that's 144 minus 4 times 1 times negative, put this in parentheses, 17,964 all over 2 times a, which is 2. And what I end up with is negative 12 plus or minus roughly 268, and we'll say 0.328. It's enough from the decimals, all divided by 2. Now, if I do the negative 12 minus that on the top, I'm going to have a big fat negative answer. So I'm only going to look at the positive version, which yields me about 256.33. I'm not even going to bring the 8 along anymore. Divided by 2, and I'm going to say that this is approximately 128. Now that's the positive answer I get for a dimension. Now remember, x is the original dimension of the square. That's where we're finding the value of x is this 0 of the parabola. And so that's why I set it equal to 0 to begin with. And we had discussed this in the previous section about why we set quadratics equal to 0 to solve. So that shouldn't be an issue at this point. And so I found the 0, I found the positive 0, and the reason I'm only focused on the positive is because I'm looking for dimensions, and we can't have negative dimensions of something. So it seems to me that the dimensions of the garden, or the planted area, is about 128 feet, and I say feet because that's the units we were in. So really this was a simple geometric situation where I just needed an area formula, but it got complicated because we were dealing with a quadratic. Now here we have something similar. It says that you have somebody painting on a sheet of paper that's 20 inches by 15 inches. Okay, so that's this piece right here. And then he places the sheet on a mat. The mat is the gray piece right here. And it's uniformly wide. So what they're trying to tell us is that even though this is a distance of x, that this is also a distance of x because the width is uniform all the way around. And the perimeter of the mat is 102 inches. So how wide is the strip? Now the key piece here is focusing on this concept of perimeter. So perimeter is equal to twice the length plus twice the width, at least for the idea of a rectangle, right? The perimeter is just the distance around something. So if we started at this corner and we went this way, this way, this way, and this way, and stopped there, we went 102 inches. Now, we know the perimeter of the painting, but now we want to talk about in terms of the actual painting with the additional mat space. So let's take a moment here and reformat the page. Okay, now that we get a little bit more working space here, what is the perimeter? We know that the perimeter was given to us as 102 inches. And let's just keep in mind that the units we're working in is inches. And then we're going to multiply that times twice the length. But what is the length? Well, the original length of the picture was 20 inches, plus the x on this side and the x on this side. So we got 20 plus the x on the right and the x on the left. So that sounds like 2x plus 20, or 20 plus 2x. Then we also have the width. Now the width is the total top to bottom. And again, it was 15 plus the x on the top and the x on the bottom. So I guess we have 15 plus 2x, or 2x plus 15. And so now what? Now we just got some basic algebra 1. So 102 is equal to, right? Distribute the 2. I got 4x plus 40 plus, and I almost forgot to put my 2 right here. That's 2 times the width and 2 times the length. So that's going to be 30 plus 4x. And now I'm going to combine like terms. So first I distributed. Now I'm going to combine like terms. And I'm going to get 102 equals 8x plus 70. And because this is a linear algebra problem, it's not a quadratic, I'm going to just isolate the variable. I'm not going to set this one equal to 0 because it's not a quadratic. So we got 102 minus 70 would give us 32 equals 8x. And divide by 8, x is equal to 4. And so now I know that the width of the mat is 4, and our units were inches. So it just says, I go back to the question, how wide is the strip of mat showing? I guess the strip of mat showing is 40 inches, or 4 inches rather. Now for my check is, again, twice the length plus twice the width should give me my perimeter, and I should get 102. So I have 20 plus 8 is 28, and 2 28s is 56, and then 15 plus 8 is 23, and 2 23s is 46, and 56 and 46 is indeed 102, and 102 equals 102, so check. So I feel pretty good about our final answer over here. In our next problem, we talk about a rectangular building lot where the lot is 8 feet longer than it is wide. So we have a width and we have a length. And then we have this idea of area. So the only two things I really know how to do with rectangles is determine its area, determine its perimeter. Now, just a point of mention, square feet tells me that this is two-dimensional, versus cubic feet would tell me that this is three-dimensional or 3D. And if it were just feet, then that would be one-dimensional. And so that's why math teachers get so upset about, forgetting little things. Like, oh, just forget a little 2. Is that a big deal? Yes, because by omitting that 2 is a completely different sort of numerical value, right? 2,900 feet would be simply just a straight line, whereas 2,900 square feet is two-dimensional space. So it's a big deal in terms of definition of a number. So area is equal to base times height, or sometimes people say area is equal to length times width. Again, these letters are really just arbitrary. It's something times something. Again, two-dimensional space. Now, what do we know? We know that area is 2,900. Now, just because it's square feet doesn't automatically make it quadratic. It has to do with whether or not we have x or x squared. So let's see what happens on the other side of this. On the other side, we have our base and our height, or our length and our width. And so what do we know? It's 8 feet longer than it is wide. So x can be our width, and x plus 8 could be our length. Or I could say x is the length, and x minus 8 is the width. Now, I prefer the white version because it has addition. Right? The blue version will work, but it has a negative in it, and I just prefer not to bring negatives in if I don't have to. Conversely, if they ever use like twice the length of, so sometimes you could use x and 2x, or you could use x and 1/2 x. Both of these setups satisfy one being twice the other size, but I prefer the top version and the bottom because it avoids the fraction. So it's all about good choice. So we're going to say that x plus 8 is our length, and x is our width. And now, what do I know? I know that x is the width of my building, and that's in feet. So now what do we do? Let's distribute the x. We're going to get 2,900 equals x squared plus 8x. And then I'm going to subtract the 2,900. Notice I put it underneath the plus 0 out here, right? Those are like terms. And I'm going to set this quadratic equal to 0. Why? Because that's how I solve quadratics. Now again, because I have that 2,900, I am going to choose to use the quadratic formula to solve this one. So I'm going to say that A is equal to 1, B is equal to 8, and C is equal to negative 2,900. We already wrote the quadratic formula down on the previous page, so take a moment, press pause, and finish this one out on your own. So as you can see, my initial setup of the quadratic equation is here. The opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So when I take the discriminant and get that all down, the square root of that was a perfect square, which leaves us with 8 plus 108 and 8 minus 108, all divided by 2. Now, for arithmetic purposes, just keep in mind that there's implied parentheses in the numerator, so I need to deal with that addition and or subtraction first before I do the division, which is in working order with PEMDAS, but a lot of students miss that. So don't do all of that in one fell swoop on your calculator. So negative 8 plus 108 is 100, and 100 divided by 2 is 50. So I'm going to stick with that as my only answer because, again, we're talking about dimensions and you can't have negative answers. So what is x? X is our width. So this is 50 and this is 58. And we were talking in terms of feet. So it's a 50 by 58 foot building lot. And when we take 50 times 58 and multiply it, we should get 2,900. And 50 times 58 is equal to 2,900. Check. Right? So this is our answer check, right? And here is our final answer. So the dimensions of the lot are 50 by 58. I don't want to spend too much time here, but it says find the length x in the figure. The area of the shaded region is given. So you have these L-type pieces. So we're dealing with an area, but there is no such thing as an area formula for an L. So I guess what we'll do is look at these pieces in terms of two rectangles. So you can either look at it as a rectangle right here by this one, or we can also look at it as a rectangle like this by this one. And it really is 6 to 1/2 dozen. It's just personal preference, however you want to work this. I'm going to leave it like that since that's the second one I drew. So then I guess the area of the whole shape is the area of two individual rectangles, which would be base times height and base times height, or again, length times width plus length times width. And so our total area is 144, and that's going to be equal to a 10 by x plus a 6 by x. And then this is just a linear algebra problem, so combine like terms and move on. For part B, I'll just do it like this. These two rectangles like that. So again, area is going to be equal to a base times height plus a base times height. So I have 160 is equal to 14 by x. And on this other one, it's slightly different. This was 10, and this was x, and this was 6, and this was x. But here I have something just a little bit funnier. I don't know what this length is. And I never knew what this whole length was. So either way, I was going to have this problem. So 14 by x definitely takes care of the blue rectangle. Now let's call this one the red rectangle. Well, how long is that? That's going to be plus 13 plus this extra piece here, which was x. So that's my base or length, whatever, height, whatever you want to call it, the left to right dimension, and the up and down dimension is x. So we're going to have 160 is equal to 14x plus 13x plus x squared, because I have to distribute that. Now we have ourselves a quadratic, so you're going to have to subtract 160 from both sides and also combine like terms here. So we're going to get 0 is equal to x squared plus 27x minus 160. So for this one, you're going to have to use the quadratic formula to complete it. This one is simple, just combining terms and isolate the variable. For your final answers, for A, you should get that x is 9 centimeters, and for B, you should get that x is 5 inches. Notice centimeters and inches. The area given was in square inches and square centimeters because area is two-dimensional, but when we finally go for this missing dimension, this length, that's just one of the two dimensions, so that's just centimeters or inches, respectively. I'll leave you to finish those on your own. See me if you have questions. Our last example will be a dimension of a garden. Again, immediately, rectangular garden. So let's draw a rectangle. It's 10 feet longer than it is wide. So again, I would prefer to call the smaller number x and the longer number x plus 10 as opposed to x and x minus 10. And then I have area. So area of a rectangle is base times height. And, or again, area is equal to length times width, as they're using longer and wide. So we'll use letters that are appropriate for their language. And I have 875 is the total area. And that's going to be times x plus 10 is my length, times my width is just x. Again, we have some distributing to do on the right side. So 875 is equal to x squared plus 10x. And I'm going to subtract 875 from both sides. Again, notice I'm putting it under the 0 there. And I get a nice quadratic set equal to 0 that I can easily apply the quadratic formula to in order to solve. Now, this is probably factorable. There's probably two factors of 875 that have a difference of 10. Feel free to fish around for them if you'd like, or just use the quadratic formula to get the wheels in motion. you should get a final answer of width of 25 and a length of 35. When you do solve for x in your opposite of b, plus or minus the square root of b squared minus 4ac all over 2a, if that's the way you go with this route, just keep in mind that x is equal to the width. So when you find the value of x here, the positive value, that's the answer to your width. To get the length, you're going to add to that. If you go the route of just factoring, you're going to get a plus and minus answer for x. Obviously, you're only going to use the plus. And that about takes us through the whole concept of modeling with equations. Hope this was helpful.